Next question, that is question number 25. A fixed pulley is driven by 100 kg mass falling at a rate of 8 meter in 4 seconds. It lifts a load of 75 kgf. Calculate the power input to the pulley taking the force of gravity as 1 kg as 10 Newton, the efficiency of the pulley, and the height to which the load is raised in 4 seconds. Now it's a long question, but everything is given in the question itself. We will try to translate in our own language. We'll try to understand. A fixed pulley is driven by 100 kg mass falling at a rate. So 100 kg is what? A fixed pulley is driven by, means you are driving. So what is that? That is nothing but your effort. That is 100 kg. At a rate of 8 meter in 4 seconds. So it is moving at a rate of 8. So it is 8 meter is the distance moved in 4 seconds. If it lifts a load of 75 kgf. Now here the load is in kgf. Calculate the power. Power formula is work upon time. Work is equal to F into S. Force into distance. But force is mg, or in other words you can say in this case your work is nothing but the energy, which is mgh. Mass is 100. G is given as 10 in the question. 1 kg as 10 Newton, which means that it is G is 10. Into height. Height is 8. In time 4 seconds. So mgh by time, if you do it, you get the answer as 2000 watt. That is the power. Efficiency. What is efficiency? Efficiency is your MA upon VR. So first we need to find is MA. MA is load by effort. Load is 75. Effort is 100. So 75 by 100 is 0.75, or you can say 75. MA is 0.75. Now, if load moves by 1 centimeter or 1 meter, the effort will also move by 1 meter. It's a fixed pulley. So VR is 1 and VR never changes. Even if efficiency changes, VR never changes. So efficiency is MA by VR. Your VR is 1. MA is 0.75. So even your efficiency will be 0.75, which you can say as 75%. The height to which the load is raised. Now if your effort moves 8 meter in 4 seconds, so your load will also move 8 meter in 4 seconds. So answer is 8 meter. Why? Because your VR is 1. Clear? Next. A single fixed pulley and a movable pulley, both are separated, used to lift a load of 50 kgf to the same height. Compare the effort. Okay, that is the question. Now we have a fixed pulley and a movable pulley. What did we study about fixed pulley and movable pulley? Fixed pulley, your MA is 1. Movable pulley, your MA is 2. Load is 50. If load is 50, in single fixed pulley, even your effort will be 50 because MA is 1. But in movable pulley, your effort will be half of it because your MA is 2. So MA is load by effort. Effort will be load upon 2. So it will be 25 kgf. Compare their effort. Compare means you need to find the ratio. So ratio of fixed pulley upon ratio of movable pulley. So you will get 50 upon 25. Effort of fixed is 50 and effort of movable is 25. You divide it, you get the answer as 2:1. Clear? Next. In a block and tackle system. Now remember, block and tackle system means what? Vertically. The pulleys are, we are trying to hang it vertically. In a block and tackle system consists of 3 pulley. A load of 75 kgf is raised with an effort of 25. Find MA, VR and efficiency. What did we study about block and tackle pulley? If there are 3 pulleys, the VR is 3. If there are 4 pulleys, VR is also 4. Here there are 3 pulleys, so VR is 3. Your MA will be equal to load upon effort. So load is 75, effort is 25. When you divide it, you get as 3. So your efficiency will be MA by VR. MA is 3, VR is 3. Your answer is 1. So it is 100%. 100% efficient. I repeat, your VR will always be the same. VR does not depend on efficiency, but your MA depends. So if MA changes, your efficiency also changes. But in this case, your VR and MA both are same. So it is 100% efficient. Moving on to the next sum. A block and tackle system has 5 pulleys. If an effort of 1000 is needed in downward direction to raise a load of 4500, same, find MA, VR and efficiency. Since it has 5 pulleys and block and tackle system, so VR is equal to 5. Straightforward. Now to find MA, I will use the formula load upon effort. Load is 4500, your effort is 5000. When you divide 0, 0 gets cancelled, you get 45 by 50. That is 9 by 10, that is 0.9. So your effort, sorry, it is 4500 by 1000, sorry. So it will be 4.5. Now your efficiency is MA by VR. MA is 4.5, VR is 5. So you will divide 4.5 by 5 into 100. You will get 90%. Why it is 90%? Because your MA is less than VR. If MA was equal to VR, your answer would have been 100%. But it is not an ideal machine, hence it is less than 100. Next. A pulley has a velocity ratio 3. Draw a diagram showing the point of application and direction of load, effort and tension. If lifts a load of 150 Newton by an effort of 60, calculate its mechanical advantage. Is the pulley system ideal? Give reason. So VR is 3. VR is 3 means there are only 3 pulleys. In such a case, you will put 2 pulleys on the top strand and 1 at the bottom. Because the upper pulleys are fixed. So the mass does not matter. But the lower one, the mass should be as less as possible, else your efficiency will change. So I will draw 2 pulleys on the upper strand and 1 at the lower one. I will draw the strands, that is the strings. I will put the load at the center of the bottommost pulley and effort. You have to mark the tension. Tension is always in the upward direction. So that is the diagram. Load is 150, your effort is 60. So your MA is load by effort. 150 by 60. So 15 by 6, it is 2.5. Now find VR. Now VR is straightforward, it is 3. Is it efficient? So find efficiency MA by VR. MA is 2.5, your VR is 3. So 2.5 by 3 into 100, you will see that it is approximately 83%. So it is not an ideal pulley, because if the pulley wants to be an ideal pulley, its VR should be equal to MA. In this case, MA is less than VR, so it is not an ideal pulley. Next, the figure shows a block and tackle system of pulleys used to lift a load. How many strands of tackle are supporting the load? Draw the arrows to represent the tension. In each strand, find the MA. If the load is pulled by 1 meter, how far does the effort move? How much effort is needed to lift a load of 100 Newton? Since there are 4 pulleys, the number of strands are also 4. Strands are nothing but number of strings between 2 pulleys. Always between 2 pulleys. So you check the top one and the bottom one. On LHS you have 1. Then second and last one, you will see the second one. Then the middle one, you will see the third one. So 3 strands. And between effort and topmost, that is the 4th one. So always number of strands will be equal to number of pulleys. In this case, it is 4. Arrow of the tension is always in the upward direction. what is the MA? In this case, your MA you need to find. MA will be equal to 4. Why? Effort is equal to tension and there are 4 strands, so 4T. Load is 4T. So your formula is MA is load by effort, 4T by T, answer is 4. And 4 pulleys are there, so VR is also 4. If load is pulled by 1 meter, so your load arm is 1 meter. So VR is 4, multiply 1 by 4, it will be 4 meter. So your effort will be moved by 4 meter. How much effort is needed to lift a load? Now your MA is 4, MA is equal to load by effort. So 4 is equal to 100 by 4. Okay, so your effort will be only 25, that is 100 by 4, that is 25 Newton. Clear? So write the E part will be only 25 Newton. A block and tackle system has VR3. Draw a label diagram of the system indicating the points of application of load, effort. Man exerts a pull off. Now he is exerting a pull, means he is applying a effort. Effort is 200. VR is 3. What is the maximum load he can raise if its efficiency is 60%? Now from efficiency, which is 60, you can find first MA. Efficiency is VR by MA. VR is given as 3. Efficiency is 60. First find MA. When you find MA, you get MA as, find MA first. So 60 upon 100 is 3 by 5. 3 by 5 is equal to 3 upon MA, you will get it. Efficiency is MA by VR. So when you cross multiply, you will get 9 by 5. Approximately, you will get 9 by 5, that is 1.8. Your VR will, MA will be 1.8. Now, MA is 1.8, load upon effort. Your effort is 200, so your load will be 200 into 1.8, that is 360 kgf. Now here on the screen, the formula they have used is different, but you can use a simple formula. First find MA. From MA you can find the load, it is 360. If the load end moves the distance 60, if load arm is 60, what distance is effort? So you need to, if effort end is 60, you need to find the load arm. So VR is equal to dE by dL. So 3 is equal to 60 by dL. So you will get 60 by 3, answer is 20 centimeter. Okay, so it is 20 centimeter. Next, you are given 4 pulleys and 3 strings. Draw neat diagram, label diagram to use them so as to obtain a maximum mechanical advantage of 8. Now 4 pulleys and 3 strings. Remember, if I use 4 pulleys as block and tackle system, your VR will be 4, your MA will be 4. But here you need MA to be 8. So you will have to use the combinations of fixed and movable. So 1 fixed, that is used to change the direction, MA is 1, and 3 movable pulleys. You already know that formula of such is 2 is to n, where n is number of movable pulleys. So here number of movable pulleys 3. So answer will be 2 is to 3. So you will draw as shown, and assumption we have made is it is an ideal machine, means 100% it is efficient, means it is, the pulleys are massless, the strings are perfect, and there is no friction. Clear? So to conclude, what did we study in this chapter? We studied about lever, then 3 types of lever, and we also studied the pulleys, 2 different types of pulleys, that is block and tackle, movable and single, and the combination of it. You have numericals. Numericals are scoring of this chapter. Theory part we have completed. What you have to do is take the textbook and do the remaining sums. Okay, the remaining sums are based on the sums which we have done it. There is nothing new. I have tried to complete all the important questions which have come in the exam, also which might come in the exam. So we have completed the theory part. We have also completed the numericals part. Clear? Thank you.